Now we look at how to prepare for the chemistry paper. Now, before you can write a chemistry paper, you need to speak the language of chemistry. And the language of chemistry is all about the symbols of the different elements and also the ions. Now, why is that important? Now, you might think you can get away without knowing the symbols, but say for instance, they give you a question where they ask you, you've got a tin and maybe chromium half cells in a galvanic cell. Immediately, if you don't know the tin is Sn or the chromium is Cr, or maybe they ask you nickel or lead, if you don't know the symbol of the element, then you can't get the half reaction. And if you can't get the half reaction, you might end up having 0 out of 21 for that whole question because you didn't know the symbol of that element. So really, guys, you have to go down and check. Do you know lithium, potassium, cesium, barium, strontium, calcium, sodium, magnesium, and right down to the end to make sure that you can identify the correct half reactions. Right, next up, when you look at the bottom of this page, I've added all the ions, that table of ions that you memorized, I hope, in grade 10 and even maybe in grade 9. You can't write a formula if you don't know your ions, right? So you need to learn the ions once again. But remember, you don't have to learn every single one. A lot of them you will already know or you can get from the periodic table, right? Remember, everything in group 1 will usually take a +1. Everything in group 2 will have a +2 charge. Group 3, they tend to make +3 charges. Then group 7 halogens, they want to be -1 usually. That's the short route to noble gas structure. And group 5 being -3. So that will already help you with a lot of the charges. So for instance, if we look at the positive ions, hydrogen, lithium, sodium, potassium, they're all in group 1, which immediately made them +1. You only needed to know the symbol. But then we get to silver. Now, silver is one of the transition metals. You find them over here in the periodic table. And the problem with transition metals is they can usually take more than one charge. So copper, for instance, you will find 1+ or 2+. Iron, you will find 2+ or 3+. So usually they will tell you, but silver is one of those that only does one thing. It only ever makes a +1 charge. So you need to remember that because you must use that. Then mercury and copper, no problem. They're going to tell you because it could have been more than +1. It could have been +2 or whatever. And then we get to ammonium, right? Ammonium, once again, you will have to learn. Right, moving on to the 2+. Beryllium, magnesium, calcium, barium, they're all in group 2, so they're not a problem. Then there's a lot of these transition metals that they are going to tell you. And then the only ones you need to know or to go and learn is nickel and zinc, and actually cobalt as well, but that's not even on here. So zinc and nickel, they will always take 2+, and you need to know that they will take 2+, right? Then aluminium's in group 3, and all the others, they will tell you it's 3+. So actually, from the positive ions, if you know the symbols of the elements already, then there's only 4 that will require that you study them. Now with negative ions, there are things that end in "ide", then there's things that end in "ite", and then there's things that end in "ate". Right, and it's all about oxygen. If it ends in "ide", look at fluoride, chloride, bromide, iodide, sulfide, nitride. End in "ide", no oxygen, right? No oxygen, and you can get the charge from the periodic table. Things in group 7 will have a -1 charge, right? Now, exceptions, obviously, something with oxygen in there, like oxide and hydroxide. They will obviously have oxygen. Right, then moving on to ite and ate. Ite and ate. You obviously find ite and ate a lot. Ite and ate. Right, what's the difference? Well, when you look at them, all of them will have oxygen in there, right? But ite will always have less oxygen than ate. So ite have got less oxygen and ate has got more oxygen. And that will immediately make it easier to learn. And also when you get to something like dichromate, Di, meaning two chrome, right? 2 chrome. And 8 is telling you there's going to be a lot of oxygen. And then you just have to learn 7 and minus 2. Right. So before you start learning, go and do revision on this table. Don't leave it until right at the end. I've always got learners who tell me, ma'am, I'm going to do this right before I go into the exam hall. No, you have to do this before, because that will help you to understand the equations. Right. Now you have a lot of equations. Most of them you will find in the topic of acids and bases, but they are not limited to that. Say for instance, you have a piece of zinc that you are adding to a hydrochloric solution, right? They're telling you you've got hydrochloric acid and you're putting a piece of zinc in there. Now this can be a question on rates, and then they will expect you to be able to complete this. So you need to know acid and a metal will give you that zinc chloride solution, and you've got hydrogen gas, and you also need to be able to balance it to put the 2 in there. Right, and why are they asking it with rates? Because the moment that you get a gas as a product, you've got 2 nice methods to work out or to determine the rates of the reaction. So with method 1, you will do the reaction in a closed container and just have a small tube that connects that to something like a gas syringe, and then you will have the plunger being pushed out, so you will measure the change in volume. Or you can put the whole thing in a beaker on a scale, and if you put that on a scale, obviously since you have the hydrogen gas escaping, right, it will get lighter and lighter. So you can either measure the change in volume or the change in mass, because with rate of reaction, let's say reaction rate, you will always have the change in something that you can measure, like concentration or volume or mass, per unit time. And remember, per unit time. It can't be rate if it's not per unit time. You really have to refer to unit time every time you talk about rate. Okay, but enough of that. Let's move back. Let's talk about chemistry in general. Now, first off, there's the stoichiometry. Stoichiometry, all the mole calculations, you need to go and redo all that mole calculations. Guys, you find mole calculations in organic chemistry questions, in rate questions, in acids and bases. So you'll find it all over. So don't underestimate how many mole equations there can be in that one exam paper. So go and recheck that. Then energy and chemical reactions, that all about endo and exo and delta H. Rate of reaction, we've already talked a little bit about rate. Remember, rate means per unit time. So every single answer that you give, a motivation for why something is going faster or slower, must end up per unit time. If you don't include that per unit time, you're not talking about rate, you are not answering the question, right? And then obviously for a reaction to progress, right, we are looking at that collision theory, and it is all about the effective collisions, right? The number of effective collisions per unit time, right? And remember, it's not just collisions, it's effective collisions, collisions that result in product. If they don't result in product, they don't make your reaction happen. The reaction is not progressing, right? So you need effective collisions. So they need to have enough kinetic energy to provide that activation energy, and their orientation needs to be right. Okay, so remember, every rate question you must end with more effective collisions per unit time. Right, then moving on, chemical equilibrium. We've done a lot of that, especially go and look at the graphs, how to interpret, how to draw graphs. Acids and bases, we've looked at that as well. Just be very careful. There's small things like the hydrolysis and the choice of indicators and things like that. Electrochemical reactions, make sure you know the difference between a galvanic and an electrolytic cell, right? galvanic and electrolytic, and then also there's a few applications of electrolytic cells that specifically prescribe things like plating and extraction of aluminium, or purification of copper and preparation of chlorine gas. So go and look at the applications that they specifically prescribe for you, because they're going to ask that. Next up, fertilizer. Guys, 18 marks, 12%. That is a lot of marks for fertilizer. And fertilizer is not a big topic, right? It's a small topic, but you really have to focus on that processes. You have to have the processes 100% correct, because they are going to ask this on diagrams. And if you can't interpret what you've done in your diagram, then you are going to lose your way and you won't be able to answer the questions. So learn the processes very well so that you can interpret. Next up, we're looking at organic chemistry. Now, there's a lot of things that go wrong with organic chemistry. One of the things that go wrong is you don't read the questions. So if they ask you to name something and you write the formula, then obviously you will get 0 marks. Or if you ask you for the formula and you give the name, then obviously you've got 0 marks as well. Also, if they ask you a question and there's only one answer, and you go and write a few answers, they're not going to check and see which one is correct. They're only allowed to mark the first one. So it's no use writing other things that might also be correct, right? Write the correct answer first. Then the other thing that happens over here is sometimes learners answer the wrong question. If they ask you for structural formula, they are looking for the whole structure and you have to show all the bonds. But if they're asking for condensed, then you have to show only the atoms, how they combined, right? So be very careful that you don't mix up that one and that one. Or if they ask you molecular formula, remember for molecular formula, everything in the molecule, there's 4 C's and 10 hydrogen in there. Then empirical, remember that's the smallest ratio. So instead of 4, 10 to 5 is the smallest possible ratio. That's the empirical one. Then general formula, that is like CnH2n plus 2 for an alkane, right? It's true for all the members of that homologous series. And then they can also ask homologous series and functional group. So obviously if they ask you the general formula and you give the functional group, they can't give you marks, or the other way around. So be very careful what they're asking and answer that question. Right, then we get to polymers. Right, guys, with polymers, what I want to say is don't study too much. Go and check your exam guidelines, right? The exam guidelines only require a few things. Say you're looking at the uses of polymers. The exam guidelines tell you that you only have to know the use for polythene. So don't go learning the uses for this type of plastic and that type of plastic. Don't spend time on that. Just do exactly what the guidelines expect you to do, right? So go and check that you don't learn everything in your textbook, and some of that is just as enrichment, right? Go and check what's in the exam guidelines. Right, now guys, I have finished with the basic ones. If you turn the page, you will see on the next page we are starting with physics definitions. Now there are 10 pages here, 5 pages, I think 5 pages. The first part is for physics definition, right? And then we get to, let me see, a lot of physics, right? A lot of physics, maybe that's 6 out of the 10, right? But then we get to chemistry definitions, and these definitions, they come straight out of the Department of Education exam guidelines. So you can keep this 10 pages and you can study this, and if you have all 10 pages of definitions, then you know that 15% of memorization, most of that is going to be definitions, and I've got the definitions, right? Then for the worksheets that I've given you, this time the worksheets are not questions that you have to answer. This time for the worksheet, I gave you 2 tables. Now the one is for physics and the second one is for chemistry. Right. I gave you all the topics with the different sections in there. And you can use this when you set up your schedule, when you plan your study timetable. Right. You can see, okay, for Newton, I need to do that. How much do I remember? What should I write down? Remember, you are in charge. Right. Now, this will help you to take charge because these are the topics that have to go onto your timetable, onto your schedule for studying, right? So there you have the physics and there you have the chemistry. And then as you go along, go and mark it. If you've learned the definitions for Newton, mark it off. You will feel a sense of accomplishment if you've done a lot of this, right? And eventually we need to have every single cell filled, right? Then you are ready for the exam. So guys, I hope you have a good time studying. Be in charge. Focus on your study and think about your thinking. And I hope you have a very good exam paper and very, very, very good results.